Hello, my name is Cesar Fernandez, and I am going to give you a 15 minutes or around 15 minutes chat about my study, which is related to speech recognition and emotion recognition. So let's go for it. As an introduction, I will tell you that basically what speech recognition does is to transcribe audio into written words. But this is only the first level of speech understanding, because emotions can transform the message completely. So this is really important for machines to understand the message. And I would say discovering emotions is also a relevant topic itself. The traditional approach towards this problem was based on the fact that there are relationships between acoustic features and emotions. And these acoustic features can be derived from the audio wave, as we will see later across the slides. There are a variety of machine learning algorithms that have been examined to classify emotions. For example, hidden Markov models, Gaussian mixture models, nearest neighbors, linear discriminant classifiers, artificial neural networks, and also support vector machines. These are some examples, and we will focus in how convolutional neural networks can help here. So, to recognize these emotions I'm talking about, I have used the RAPDES dataset. This dataset is gender balanced. It consists of 24 professional actors. They vocalize lexically matched statements in a neutral North American accent. I would like to test in the future this with other languages, such as German or Spanish. And the speech includes calm, happy, sad, angry, fearful, surprise, and disgust expressions. Each one of these expressions is produced at two levels of emotional intensity, and there is an additional neutral expression. This information is encoded in the file name. I will show you. Uh, these are the file names. I have downloaded more than 1,000 files, 1,440, and I will show you in my code that the name of the file is used to encode the information. For example, you can see here the emotion is encoded as a number, and I use this to extract the labels based on the file names. Okay, so let's continue. And you can download this from this link that I provide in the slide. And as I mentioned already, I used for my study 1,440 different audio files. Okay, then let's go now to the work itself. Basically, as I already mentioned, the idea is to try to find features in the speech to help recognize emotions. I show you here the topology of different waves for the same speech, and these different waves correspond to different emotions. Some things can be discovered here. If you see, for example, the final part is different, even though there is certain structure, but of course, detailed work is needed to get more insights. I have, for educational purposes, shown the information in the frequency domain. As you see here, I show the Fourier transform. As I said earlier, in the waves with more detailed work, we can zoom into the frequency domain and try to understand or try to find features on these frequencies to recognize the different emotions. But this requires detailed work. I also showed here, again for educational purposes, the spectrogram. And I mentioned before that the approach to solve this problem is based on the fact that there are relationships between the acoustic features and the emotions. And we talk about acoustic features, concretely the male frequency cepstral coefficients, and this is what we get in our code in order to train the network and recognize the emotions. Okay, So as I'm mentioning, what I have done is to train different convolutional neural networks with the training data I have been talking about to recognize the emotions that I have shown here. So first I will go through the results, and then I will show you how my algorithm can recognize my own voice. Then let me go for the first convolutional neural network. I have taken this first network from a paper called Speech Emotion Recognition Using Convolutional Neural Networks. This was written by Somayesh Shashasvarani from the University of Nebraska-Lincoln. And here is the summary of the network. Basically, it has around 750,000 trainable parameters, as I show here. And the accuracy I got with this model is around 40%. I can see here that after a few hundreds of epochs, the model started overfitting. I say here around 300, 200 to 300. So I was not super happy with this 40%. Then what I did is to go for a second model. So what I did for the second model is to modify several ideas I saw, and I designed this convolutional network. In this case, I have 667,000 trainable parameters, as I show here. And the accuracy I got with this network was around 55%. Again, after a couple of hundreds epochs, the model started overfitting. And important to mention that I have tried another models that I got from some papers, and I did not achieve better accuracy than this 55%. I show the models here for the reference. With this model, I got 52, a little bit more than 52. This model has 500,000 parameters, around 500,000 parameters. And another model, basically there are small modifications from one to the other. I was trying to get a little bit more accuracy, but again, this gave me 52% accuracy. Okay, so this is what I got. This is the model and how I trained the model. Now I will show a couple of examples of recognition of my own voice and how the algorithm recognizes this voice. So for that I have recorded two sample waves. Let me play them and show the output of the algorithm. I play the first one.
This program is great.
This program is great. So when I introduce this wave, this speech fragment to the model, let me go and show you the result. The prediction for this particular sample is male fearful. And now let me go for the second one.
This program is not so great.
I say a similar sentence with a different mood or tone. This program is not so great. And when I use the network with this sample, I get the prediction of male angry. So these are the emotions that the algorithm recognized based on my speech. Okay, and based on that, I have some conclusions I would like to share with you. So let me go to these conclusions. And basically, I would say that the most important thing is to mention that the accuracy I got with my different models was 55%. When I have seen that the state-of-the-art algorithms can achieve slightly more, can achieve levels of 80%. So I need to work more on this. What I need to do is get more samples to be able to train the network with a larger number of samples. And also, maybe it's worth to try different models. I have read that with recurrent neural networks, the result is not much better. That's one of the reasons why I decided to go for convolutional neural networks. Important to mention, as it can be read in the papers that I attach, that this problem is very complex because even though I already mentioned that we may assume that there are relationships between acoustics, features, and emotions, there are high dependencies such as the speaker, the gender of the speaker, the language, or the culture of the person speaking. So this makes the problem really complex because something that one person can say in a way with a happy emotion, for other person may be a little bit different. Okay. Then what are the next steps that I'm proposing here? As I mentioned, I want to train my model with a higher number of samples. I want to test the model with different languages. As I mentioned, I'm interested in developing this technology for psychological purposes to understand the mood of a person to real time provide this person with certain stimulus to provoke in this person different reactions. And for this, I need to understand the emotion based on the speech. Then I would like also to test the performance of recurrent neural networks and LSTM to solve the problem, even though I have read that the results are not great, but this is something that I want to test. And also, instead of testing the model with so many different emotions, with so many different classes, I would like to test the model with a smaller number of classes, such as positive or negative, to try to increase the accuracy of the model with a lower or a smaller number of classes. And basically, this is all from my side. Thank you very much for your attention. And I hope that this information was useful for you. Maybe you can continue my work. Thank you very much.